So I've got a small deck, and then I'm going to spend most of the time doing the demo, but hopefully this will get this window up here. So before we get started, I'm just going to do kind of quick intro, and then we can move on to the demo. So my name is Jordan Anderson. I am a managing consultant at Talivant. I've been at Talivant for 2 years now. Before that, I worked for a company. What's that? Yeah, it should be shared. I can try it again. Is it working now? Okay, cool. So I've been with Talivant for 2 years. Before that, I worked for a company called Solve out of Milwaukee, also a BI consulting firm. I've been practicing now since 2009, and been consulting for a while now, since 2001. I've been in and out of software engineering, business intelligence consulting, .NET development, all that good stuff. And primarily today I work on architecture, design, and strategy for organizations. So I'll work in a myriad of verticals as you do in consulting. But it turns out that everybody's got data problems and it's universal. So if you can fix data, you can work in any one of these industries. I'm also a private pilot. That's my passion, so I like to spend time doing, and that's what this presentation is going to have flavors of. So hopefully you'll find that interesting. This is a picture of the plane that I own a share in. So whenever I get a chance, I like to go fly for fun, but it's also a good business or excuse to fly for business and expensive. But these days I'm primarily flying for fun. And we're going to talk a little bit about how some of this aviation stuff ties in, so just getting an intro there. Before we move on, is everybody familiar with what we're going to be talking about today? The Azure Streaming Analytics, real-time analytics. Is anybody using that at all these days? How about Azure in general? Anybody working with Azure in any capacity? Yeah, primarily database stuff, or any machine learning? A little bit. Okay, cool. Well, this will be fun then. So I'll take it step by step. So hopefully we'll. Oh, that's weird. Hopefully we'll be able to cover all the gaps. I don't know why it's doing that, but we're just going to roll with it. So quick overview of Talivant. So we have 3 pillars of our practice that we focus on: strategy, architecture, and implementation. That's supposed to say architecture. So we do assessments for organizations to help them understand their current state, build a roadmap to get them to where they want to go, leveraging their data to accomplish their business goals. So that's primarily what we do in the market today. We are really solid on architecture and implementation. So our practice is primarily comprised of BI practitioners that have a lot of experience on the tech side, and so we're fully versed in all the how-to with the Azure stack, AWS, SQL Server, all that fun stuff. So talking about what we're going to do today, so we'll talk about real-time analytics. We'll just get into it a little bit, kind of why you would want to use it, where does it make sense. We'll talk about how that relates to Azure, and then we'll pray to the demo gods, because I'm going to do this thing end-to-end. Hopefully the Wi-Fi holds up, and we will be able to get this end-to-end solution built here. I did this for St. Saturday last year, so hopefully it'll play out the same way. It did work there. Quick debrief and then wrap up. So hoping to hold this to an hour, but we have a smallish group, so if anybody has any questions, feel free to chime in. If I'm going too fast or you can't see something, please stop me. All right, so real-time analytics. This is something that we can use today because of the technology we have available to us that has very low barriers to entry to be able to do analytics that we used to do on a batch job or a polling type job. We can stream that data today, and we can actually take action based upon it in real time. So we can do things like anomaly detection if we fall outside of a range of a boundary, if we have machinery that we're responsible for, say in a plant like an assembly line, proactive maintenance. So You can even do things like machine learning models that say, these are the patterns that we see with our machinery before it breaks, and then use those patterns to recognize it ahead of time and take action so you don't have the shutdown in the middle of the day. You can also do things like anomaly detection for fraud, credit card processing, insurance claims processing in real time, and then shift that into a different pipeline to take action right away. Of course, you can do things like alert the team and then have them respond, as well as kind of taking action in an autonomous format. So this is Microsoft's design of kind of what Stream Analytics works with, and it's, I love these because everything on the left is always everything, and then on the right is the Microsoft stuff. But in reality, what we're saying here is you can connect using .NET code, Python, Java, whatever the language of choice is, to these services in Azure and push real-time data. And we'll see that all today. Stream Analytics sits in the middle. So Stream Analytics is SQL language-based, where we can do real-time analytics on a stream of data and then perform that query in real time to push to any one of these outputs or build alerting or even do machine learning. So does that make sense kind of at a high level? Okay. All right, so demo. This is going to be fun. So recently, the FAA has required that all aircraft by 2020 install something called an ADS-B transmitter. And this allows us, right now, you can track aircraft. ATC tracks aircraft using radar. It does a radar sweep, hits the airplane, comes back, and then it puts it into a computer, essentially. But now that we have GPS, we don't have to do these crazy, 1950s methods of interrogating aircraft. We can use GPS and antennas on the airplanes to stream data. And it turns out that this data is unencrypted and available to everybody. So we're going to use it. And this is what the device looks like. So this is an instrument panel of an airplane, a whole bunch of instruments, but a bunch of vendors make these boxes, and essentially ATC will receive data from these in real time. You can also see these are other airplanes that are around. This is an actual airplane in the air, and this is traffic around them, showing the difference in altitude. So it's actually really great for situational awareness. If you're a pilot, it's actually been a really cool evolution in technology to be able to do this kind of stuff. So again, it's unencrypted, it's available, it's open. Aircraft are flying above us all the time, so we can always receive this data. And all you need is a Raspberry Pi. So just one of these. And here's a picture of kind of, I didn't bring all the gadgets and the antenna and everything because I think that would be kind of crazy. But here's a photo of how it's set up. There's just an antenna on the other end of this here. There's a receiver, and then this is a Raspberry Pi with a connection to the network. And so we're going to use a Raspberry Pi that's actually at my house, and it's connected to the antenna and has a software running on it called Dump 1090. It's open source software, and it creates an output stream. So just like a piece of machinery would do it, this will do it.
What system do you use?
Raspbian. So this is all running under Linux. So here's a view of the data stream. The data stream is comma-separated values, so you should all be familiar with that. We have unique IDs based on the aircraft. It's all hex IDs, so here are the hex IDs, and here I showed you this actually has its own unique hex ID, so you can tell you have a unique key here for each aircraft that we can use, and this is what the data looks like in its raw form streaming in. And then there's some other attributes, altitude, GPS coordinates you can see here, other fun stuff that we can use, time and date. So this is the overall raw stream, and then there's a key here that talks about kind of what's where in each field. So we're going to have to do a little bit of cleansing to get this data in, which is fine. Cool. All right. So here's what we're doing. I'm going to step through this in Azure, and we'll see each component. We're going to start with the Raspberry Pi that's on-prem at my house, literally on-prem. It's going to push to an Azure Event Hub, and that Azure Event Hub is going to be responsible to receive these events. That's all it does, is receive the events. And then that hub is going to be connected to Stream Analytics, which allows us to perform SQL queries in real time, and then push to Power BI so we can see the visual. All right, so Event Hub. Has anybody ever used an Event Hub? You know what the name means? Okay. So Event Hub is something that you can write code, or if you have an API that connects to it in an application, stream data. And all it's doing is it's pulling from stores, it's pulling from sources rather, and they're pushing to this service. And it's going to retain it. If you want it to, it'll store it. It'll push it to any number of destinations. You can connect to it with a bunch of consumers, and it can even keep track of, so let's see if I got this slide here. Yep. It has consumer groups, which I'll show you, but it can keep track of when the last read you did using a Event Hub was, when that last read occurred, and then give you the stream from then forward so you never miss an event. It's actually really well designed. So let's get to the demo. That's just really high level stuff. I'll start to explain the specifics in the demo, and then I'll get into the debrief here. So I'm going to try to do this end to end so you can see all the services and how it's all put together. Again, if you, yep. Oh, yep, I can do that. Second. Can you see my browser? Okay. So I just created a resource group here in Azure. So in Azure, resource groups are just a collection of Azure services, Azure resources. It's a folder so that we can logically group these things. We can do other things with resource groups, but we're not going to get into that today. So I'm going to create our first resource. We talked about the Event Hub, so I'm going to create that right now. So here it is, Microsoft's Event Hub. That's all you have to do. Click on this. These things are crazy cheap, by the way. It doesn't require a lot of investment to do this. So I'm going to try pass demo for. Let's just do a standard one. So this is for those that don't work in Azure. The location that you select is the actual data center. All their data centers are connected, but if you have a bunch of services that are going to be talking to each other, it makes sense to put them in the same data center. Otherwise, they're going to be shifting data over the wire, maybe across the country. Sometimes you'll have to do that because services only exist in certain data centers, but if you can, put them all in one. We'll just keep it at, yeah, we can do one throughput unit. We're not going to be too crazy today. So throughput units, again, Microsoft likes to split things, service units, things that you're going to pay for, into database units, streaming units, whatever it is. And as you scale that up, you pay more per month. So this is going to create. I'm also going to create one more resource just so that we're not sitting here and watching stuff get created for the streaming analytics. So Stream Analytics is the SQL query-based processor. So these are the two services that we're going to create. This is all we have to do this. Again, we're going to do North Central, and we'll put it in the past demo. So hosting environment, we're going to do this in the cloud. You can actually do everything that we're going to do today and push it down to these devices so you could have it on-prem and you don't have to hit the internet. It's really nice. It's called IoT Edge.
But that is another talk that I'm hoping to give at SQL Saturday Madison. So hopefully we can make that happen. All right, so I've got two services going here. Hopefully they'll be spun up soon. And while they're running, let me quick head back to that resource group. Okay, so looks like we've got our Stream Analytics job deployed. We're just waiting on that past demo Event Hub to be deployed. But while that's going, I'll show you how we actually get the data from A to B. So I use Python. This can also be done in C#, Java, any language that you prefer to use. And all we're doing here is Microsoft has exposed a bunch of libraries to make this super easy. So what we're doing here is we're connecting to so this is just a few variables that we have to have, the address of the Event Hub that we're sending it to, and we'll modify this once we get our Event Hub provision. Then the key that we're going to use, which is essentially the username and password to connect to it, and then a method here to send the data. So we're doing two things in this Python application. The first thing is we're connecting to the TCP socket of that Raspberry Pi at home that's connected to the antenna that's pulling data down. So we just connected the TCP port and start streaming data in. And the second thing we're going to do is connect to the Event Hub. So as we're streaming the data in, it's going to push it to the Event Hub, and we're going to handle some things here with the incoming data. So you remember that raw data doesn't have any field names, so we need to give it field names so that we can process the data downstream by field name and not by field index, or something that's a little bit more ambiguous and difficult to understand. And we're going to translate it to JSON because I found that working with JSON is usually the easiest thing when you're pushing streaming data to Azure. It understands JSON. It's easy to see what the field names are and the data that's associated with it. So we translate it here to JSON, just a UTF-8 file that gets pushed up, or a stream rather, not a file. And then we send it. So all this is doing, this is a for loop, and this is essentially saying for each row that we get, push it up to the Event Hub. And it's going to do this while one, it's going to do it forever until there's no more data. I'm also going to share this code, so you'll be able to download it and look at it more closely if you like. So this is just some housekeeping stuff, closing the connections when we're done, but the meat of it is right here. Does that make sense how this is working? I'll illustrate that here in a second. So the bursts are, gosh, I think it's like every 100 milliseconds. It's really fast. But you'll find here that the latency of my internet connection is going to be the problem. So that's why I'm doing the IoT Edge stuff in a later talk. But it is super fast. Super high velocity data. So this is the Raspberry Pi. I just connected to it here using SSH. That's sitting at my house, connected to the antenna. And here's some data I was streaming earlier. But I'll show you the Python file. So I just showed you this locally. This is the program, and then here it is sitting on that Raspberry Pi. The only reason I want to go here is to change the service, the Event Hub name, the key, and the shared access key value. By the way, if you notice, the syntax here is a little bit different because this is running an older version of the Event Hub stuff. The code here, which is what I'm going to share, is the newest version. So this syntax will work for the latest Event Hub implementation. All right, so we've got our Raspberry Pi. We've got our program on here. We've got some names that we need to update. So first thing is we need to create our Event Hub, which we've done, and now we need to get our credentials from it. So here's our Event Hub namespace. An event hub namespace can contain many event hubs. We're only going to create one for the purposes of this demo, but you can create multiple if you have different machinery that's pushing different types of data, et cetera, or different sensors. So we'll call this aircraft data. The one partition count, message retention. By the way, if you're ever in here and you want to know what these actually mean, these sliders, you can just mouse over the information icon and it'll show it to you. You can also choose to capture these to storage if you want to have a file locally or on Azure rather. So I'm going to create our event hub. So this is within the namespace, the service event hub. We're going to create one event hub called aircraft data. Okay. And I'm going to double check to see that that's there. Here we go. So we've got aircraft data, status is active. We can click on that. You see there's no requests, no messages, no throughput yet. Nothing's happened. And I can see here, sorry, under our shared access policies, which is right here. Recognize this from earlier, root manage shared access key. That's automatically created. Okay, so this is one of those shared access policies. And this is the username and password, essentially, that we can use to access this. You can create multiple access policies for these services, and you'll see this repeated in multiple Azure services. But we just need one key. So I'm going to copy that key, just click here to do it, and I'm going to bring it into our service here. So the only thing I'm going to need to change is this guy here. Paste this in. So there's our key, and we're going to change this aircraft data to the name of the event hub, the service namespace, which if we look in here, it's called past demo. So copy that, bring it in here. And the only other thing we need to change here is the name of the hub that we created. So that was the namespace up top. Here's the hub, and I can double check that by going to the event hubs here. Within that event hub, it's called aircraft data. And we should be good to go. So because Microsoft wrote this, the library to connect to all this, all the other overhead, you don't have to worry about. Now let's save this. Actually gonna, just in case our prior one was working and this one doesn't, I want to save it in a different name. So I've saved this as TCP demo 2. That's okay. It's going to work the same way. So I'm going to run it, and hopefully we'll get a successful connect. Whoops, sorry. I'm going to do Python 3 TCP listen demo 2.py. And hopefully we'll connect to the event hub. This usually takes a second to spin up the connection to both ends. Yep, there we go. So these are the events that it's receiving from the Raspberry Pi and pushing to Azure. So this is happening in real time, and if we go to Azure and we take a look at this, usually takes a little, yep, oh, there it is. So we can see we're already getting events streamed to this. And you can go into the Event Hub, should be able to see the events occurring here. So there was the one request. We'll probably start to see messages here as we get a little bit further in time, but you'll see that start to creep up, and we know it's working. We also know it's working because our application hasn't bombed. So we're going to leave this running because we've got data streaming in, so that's good. Let's now take that data. So if we go back to the deck real quick here, just to kind of highlight where we are, so we stay on track. So I'm not going to make this a full screen because I don't want to kill the Skype. But so we're here now, right? So we've gotten our Raspberry Pi, we've got the application running on it. It's running behind this window here. We've provisioned our event hub and we've connected to it. So this is the first step. and we've completed it. Now we want to analyze this data, right? We're getting all this data coming in. We actually want to do something with it. We want to start to cleanse it. So if you know SQL, you'll be able to do this. So we want to connect to our Stream Analytics service. So if you remember earlier, we actually provisioned that as part of our prep for this. So there's this past demo analytics job. This is that Stream Analytics job. All right, so the way that this works is we've got three key components of the topology. Forget about functions for now. Inputs, query, and output. So if you think about it, if you think of this as an input table, you think about the query as like a SQL query, you think about the outputs as where it's going to go, then this will make sense from a setup point of view. And we'll set it all up from start to finish here. So I'll click on inputs first. And I want to add a stream input. So we know it's an event hub. And we'll call this aircraft data. We know our event hub namespace is aircraft data. Actually, sorry, it's past demo. We created past demo. I have one in the can, by the way, if this thing doesn't work. So that's why there's two instances here. But I'm going to use the past demo here. I'm going to just take the settings that flow in because it's all Azure, so it already knows about it. It knows our event serialization format is JSON. You can also use Avro or CSV. JSON's my choice for this particular use of the service. No compression. I'm just going to go straight away. So I'll save that, and it will connect to it, and it'll add the input. So now we've got our input set up. But we want to create an output too. So let's do that. Because we want to output, remember, we're going from Stream Analytics to Power BI. So we want a Power BI output. So Power BI. Let's send Power BI, pass demo dataset, Graph Analytics. And we got to authorize our connection. Not that one. Hopefully we'll get our Power BI connection. Yep, so we did that. We've authorized, we should be good to go. So save this. So I'm using Power BI, powerbi.com, got an account there. That's what we're connected to. So we've got our input here, that should be provisioned. By the way, if you ever want to know if this stuff is done, if you don't see that line on the bottom, you can always click the bell and see that these things have been successfully completed. All right, so we've got our input and output defined. Let's define our query. So a couple things about how to query the Stream Analytics service. So in contrast to like a batch data set where we have a finite start and end, Stream Analytics is streaming data. It has no start and no end as far as this processor knows. So we have to define a time boundary for the data to analyze, especially if we're going to do something like take an average. It needs to know what's the time span that we're going to average, and it's going to keep moving that forward. So I'll quickly cover kind of how that works. So Stream Analytics, the window function stuff. So how many people have used window functions in SQL Server? Okay, so in SQL Server, you can define a time scenario and then run analytics over that particular time scenario, that time span. And this window is just that. It is a window of time. So there are three ways that you can do this in Stream Analytics. There's a tumbling window, a hopping window, and a sliding window. So the tumbling window is these distinct time segments where we're going to take a chunk of time and the events that occur in here and then move that chunk of time forward. Did any events occur here? Okay, we'll average those. Move that chunk of time forward. Any events occur here? Okay, let's average those. So that's a tumbling window. It is a exclusive section of time. A hopping window is overlapping. So we can move this forward and say, okay, we're going to average these events here, and then as we move forward, we're going to get a new event, but we're also going to continue to average the events that occurred prior. So we're going to continue doing that all the way through. This is something that, like here's a scenario, every 5 seconds, give me the count of tweets over the last 10 seconds. So here's a 5-second window, or every 5 seconds there's a 5-second window, or 10-second window, sorry. Every 5 seconds, give me a 10-second window. So here's a 10-second window. If we're only hopping forward 5 seconds and that window stays 10 seconds, then we're going to overlap. So that's the hopping window. And then sliding window, this is only going to output data when an event actually occurs. So this will, this is tied more to kind of an event-based approach, but it is certainly an approach you can take. All right, I think that's, yep. Oh, by the way, all of this stuff is documented really well. So Microsoft has all that for you. Maximum size of the window is 7 days. I don't know why you'd want to do a 7-day analysis of streaming data, but you can. All right. So I've got a quick, I've got a query here that I'm going to just paste in, so we're not spending time kind of debugging queries, but I'll step through it. So first thing is we've got our select statement, right? We've got some, this should look pretty familiar if you're familiar with SQL. And then we've got our into, which in this case we're not into. So if you do a select into in SQL, you're going to get it into a table. In here, we're going to put it into Power BI. So we know the name is PBI. By the way, this has actual, this has a built-in kind of debugger. Or a code interpreter, so it'll tell you if you have named things incorrectly. Also, you'll see here we've got aircraft data and ADSB. This is one thing that's kind of weird about this service. If you create an input that doesn't exist, it just puts it here. This is not what we want though, because there's nothing here. We want aircraft data. So now you can see it went away. So this is our input. This is the event hub. This is our output. This is the Power BI application, or Power BI in the cloud, powerbi.com. And we're using a tumbling window every 5 seconds. So just a quick reference here, tumbling window is those exclusive 10-second chunks. Or in this case, 5 seconds, but those are exclusive chunks. All right, so we've got that. We've got our query here now. So we'll just focus on the select statement real quick. We're going to do a few things. We're going to count the hex ident, which is that unique key for each box in an individual airplane, and that'll give us the total number of bursts that we've received from that aircraft. We can also count distinct to say how many unique airplanes there are, and we can average the altitude of all the aircraft above us to say what's the average altitude that they're at. We also have a timestamp here so that we can do time series analysis. And then finally, we've got some data cleansing stuff in here, essentially saying, don't give me aircraft that are either misreporting by not reporting an altitude at all, or if they're on the ground, don't really want to know about that. And then we've got our group by. Does that make sense, kind of at a high level, how that works? So I'm going to save this. So now we should be good to go. We've got our input, our output, and our query. So all we have to do is start the service. Hit start, and we'll say, so this is, you can see, because this is connected to a consumer group, I can choose to do the job output start time as now, a custom start time, meaning I want to set it back to when I last left it. You could just choose this, or another time, or when I last stopped the service. So if you stop the service and you want to get all those events that occurred while the service was stopped, you can click this, and it will go back to that time. So really well-built system. So this is just starting up. This takes a minute or two, so I'm going to just cover a few things before that gets spun up, and then we'll move on to Power BI. So there are, if you think about kind of, you've got an event hub, you're streaming data to it. If you're looking at the event hub and all you're seeing is the wonderful graphs like this, these charts, and they're good and all, but if you're trying to debug something, you don't really know what the events are. Well, does anybody here use Visual Studio Code? A little bit? Visual Studio Code is the kind of open source, you know, all platforms version of Visual Studio. And so that actually has a really cool plugin or extension that lets you monitor the Event Hub messages in real time, and you can see the raw event messages coming in before you do any analysis, just to make sure that your application is actually working. So you can do that in VS Code. You can also, so what we're doing today is actually a real, like, you know, physical device in the real world. But you know, when you develop these services or you want to learn them, you can spin up a device that's, you know, virtual. It's a truck, it's a refrigerator, it's a, you know, a machine, and you can say, you know, give me this device that's either working properly or faulty, and it will send you data that's according to that, so that you can start to do things like anomaly detection and handle proactive maintenance and all that good stuff. So Microsoft has got a solution out there. This is their accelerators for this stuff. So I'll share this deck. This link is actually really good. I had some fun with this stuff when I was learning it. All right, so we should have our service spun up here. So let me go to past demo. Analytics. Okay, it's running. Don't see any issues. If there were issues, sometimes you'll see an exclamation point here. If it's running in a degraded state, it will tell you that there's a problem, but here we don't have that. All right, so we've got our data now. We've got it streaming all the way to the service. So we've gone from the Event Hub. Now we're streaming into the Azure Stream Analytics service. And now we want to visualize the data using Power BI. So I'm actually going to go, spoiler alert, I'm actually going to go here and refresh our data sets here. Hopefully I'll have our new data set. Not yet. Sometimes it takes a second. Oh, wait, sorry, not data sets. Here we are, data sets. So ignore these two. In fact, yeah, these are from earlier demos, 125.47, 2017. So this one's today. This is what was just created. So by connecting Stream Analytics to the service, it's actually created a data set automatically in PowerBI.com. And you can see the different components to it. So here's all of our, if you remember the field names we specified in our query. Here's the JSON, some JSON data, just to kind of, I guess, see the way that it would look in raw form. And then you can also see that it's inferred the data type. So we've got our data set. We can actually do something with that. So we'll create a dashboard. So I'm going to create a new one here. Demo. Let's add a tile. So on the bottom, real-time data, custom streaming data. That's what we want. And then you can add a streaming data set. This is for like third-party streaming data sets, or you can use one that you've already created. So we've got the one that we created here called past demo data set. And now we can, just like any other Power BI visual, create the type, set our axis. Of course, we want time, and then we want to have our values. So let's say we want to just count the number of bursts that we're receiving from aircraft. We can do that. Hit next. Count of bursts. Apply. I can take this guy and move it over. You can see it's scrolling. Actually, I made it a little too big for this browser, but you can see it scrolling, and I'm not scrolling it while it's doing that. This is when it's receiving the data. So this is actually connected now to that Stream Analytics service, and we're visualizing it in Power BI. So we can do stuff like, you know, say we want to put this up here, and we want to visualize, okay, how many let's just add a quick one for unique aircraft. So how many of those are unique? And we want this to be a line chart. So unique aircraft. Next. Okay. Apply that. Now down here, we've got a second one that's streaming in real time. So this data is now gone from this application that we wrote that's streaming data, just this raw data in JSON format to the Event Hub, to Stream Analytics that's doing some aggregation and cleansing straight into Power BI, and now we're visualizing it in real time. Does that make sense, kind of how we got from A to B? It's actually really well designed. I was surprised. The only thing that is a challenge here is the limitations of Power BI's visuals. So if I were going to do this in the real world, I would probably roll my own. There are some things here that we can do, like, really high level, but if you notice when I was adding a tile, once you select this custom streaming data, you get to see like 5 different types of visuals, and you can't do a whole lot of customization. So if I were going to create a robust dashboard that was real time, I probably would roll my own. But it is working, and it's something that we can present and actually use in the business to see how we're performing. So if you think about sensors in a data center, and you have multiple temperature sensors, and you want to know, like, when does the data center temperature increase above 75 degrees? We want to send an alert. We want to see the average temperature, that kind of stuff. We can do all of that in Stream Analytics, and we can surface all of that data in Power BI at a high level and see the performance of all these devices. And I think, yep, that pretty much wraps it up for this demo. By the way, if you're interested in the IoT edge stuff, meaning not doing this in the cloud, but pushing it down to these individual devices so we don't have to deal with the latency of the internet connection, there are some really good tutorials online, and I'm submitting to SQL Saturday, so I can't say that I'm going to present in Madison, but I'm hoping to present on that specific topic. If not, I'll arrange something else. But with that, I will take any questions. Yeah, so this is more applicable like in assembly line plants, things like that, where you're doing predictive maintenance, you're doing, machine learning based upon, either camera data or sensor data or whatever it is, and then sending that data back into some kind of a control process or an alerting dashboard or stuff like that. That's where you're going to see more of the streaming stuff. But you can also do it with things like weather and Microsoft has this commercial right now where it's like, we can predict crop cycles and when to water properly, and all these different sensors that they put in farmers' fields. Like, that is a streaming analytics solution. But these days, not everybody is kind of there yet. This is just getting started. I think we're going to see more of it, though, as we start to get more IoT focused. This will start to become more prevalent.
To add machine learning for that, what
so you can actually create machine learning connections in your Stream Analytics job. So you can actually feed it in here into a model. Running the job, but stop the job. But you can actually add it, and it'll let you add a machine learning model here, and it will process it just like we're processing here through the query, but it'll send it through the model and then get the output and push it out. Mm-hmm. So like unstructured meaning like an image or video. Yeah, it's not structured. Mm-hmm. Yeah.
It's very random.
It really depends on your particular application and what you're going to do with it. If you're going to build a machine learning pipeline, you could certainly take that unstructured data, and you're going to have to put some kind of controls around it, to apply it to the model. But you can certainly take an image and stream it to a machine learning model and do some image recognition stuff. I haven't really seen much of that kind of stuff. It's been more like if you're talking about like credit card processing, real-time transaction, anomaly detection that way, that's a machine learning application. Cell phones, so when people are stealing other people's SIM cards and making calls that are outside of the norm, you can detect those calls in real time and potentially stop that activity. If you think about like toll booths, where we have some OCR data coming back and we're processing that in real time to essentially turn a light red or green, you can do that, and then feed data back to the, the data, to the analytics layer to see like, how much are we collecting and all that. You can do that in real time. But as far as like processing unstructured data, like, I guess I just haven't seen that. I'm sure it's possible, but I haven't streamed like video and analyzed that in real time. I have done machine learning models that run on a device that detect like a car. If a car is in a car is in the image, where is it and what type of vehicle is it? You can do that. I just haven't done it with Stream Analytics. I'm sure it's possible in some way, but it just depends on the application. Any other questions?
So if you stop the event handler, how does it say where it's breaking?
So if I stop this, this is a good opportunity to just, this shouldn't take long to stop, but I'll show you what happens. So when we start it back up, it's going to ask us where we want to pick up from, if we want to pick up from where we left off. And so we can say, we're streaming, by the way, like when this is stopping, this application is still streaming stuff. So now we're processing data into the Event Hub that we haven't picked up into our query or done anything with. So now there's a gap. Hopefully this won't take too long to stop. But when we restart it, it's actually going to ask us, do we want to restart it from wherever we are right now, meaning the last line in here, or do we want to restart it from a time that we know of, like do we want to start from midnight, or do we want to start from the time that we stopped it? When I click the stop button, it keeps track of that time, and then it will go back and get all of those events. So if I do when last stopped, it will actually go back to when it was last stopped, and then all of the events that it's capturing right now and retaining, it will reprocess those and then catch up to real time. So
if you stop your Power BI, is kind of,
yep, my Power BI, if I go here, it's flatlined. It's done. But you have the option to stop. By the way, like if you're going to edit this query, you have to stop the service. So you stop the service, you edit your query, you restart the service. So that's a good application for saying, okay, I'm going to start from where I left off and get all of that data back. But it depends on your application too. You might want to say, well, I just want a real-time view of how X is working. You might just want to pick up from where things are right now. Just depends.
the event handler pulling all that data from the pie, that getting in an Azure cloud.
Yeah. So all of this, all of the data that you see here that's being streamed is actually, it's stored in the Event Hub itself. And when I provision this, I set the retention period to 1 day. So it's going to keep things for a day. You can change that to, much longer. But right now I only have 1 day. You can also say, I want to capture this stuff and put it into like blob storage, just like a file share, where you can go back and see those files individually and process them. Like say, for example, you have a streaming side and you have a batch side, kind of that Lambda architecture. You can do both with this service, and you don't have to say like stream the data here and then do it again to another point. You can do it all in one Event Hub. Any other questions? Cool. Well, I hope this was enjoyable, at least get some exposure to this stuff. You can tell I have a little bit of passion behind it because I thought it was a really fun demo to do. But yeah, I mean, it is cool to see how Microsoft is evolving these services. They're really putting a lot of work into this stuff. So if you want to reach me, here's my email and my LinkedIn. I'm pretty active on LinkedIn, so if you shoot me a message there, you'll get a response quickly. But same goes for email, so whichever you prefer. And then, yeah, I'll send the slide deck around and our sample code. But yeah, thanks very much. Turner, can I hang up?